So in this video we are going to continue with our differentiation topic and we are going to look at stationary points. Now we previously saw this diagram. In the last video we can see where the curve is increasing up to this turning point, it then starts decreasing to the next turning point and then it starts to increase again. But there are also some points on the curve which may neither be increasing nor decreasing. So namely here, so what I've been referring to as turning points. Now you'll have met turning points, we've talked about before, you'll have met these last year in National 5 when you looked at quadratic graphs, and we actually say that the curve is stationary at these points. That's why we call them stationary points. Now the gradient of the tangent to the curve at these points is 0, because the tangent is actually a horizontal line, and we know that horizontal lines have gradient 0. So we can actually find these points by solving dy by dx equal to 0. Now, there are 4 possible stationary points. 2 of them you will have met before in National 5, and those are the minimum turning point. So what you can see here, curve comes down and it's a minimum turning point almost at the bottom of the curve, if you like. We have a maximum turning point, where the turning point happens at the top of the curve. And you can see for both of these I've put in that horizontal line for the tangent so that you can see that the gradient is 0. We then have a rising point of inflection. And what you can see here is the curve is increasing. The stationary point happens and the curve continues to increase. Now that's quite a different behaviour from the first 2 options, because in the minimum turning point it was decreasing, the stationary point happened, it was then increasing, so it changed, the gradient changed. The same here, it was increasing then decreasing, but here, like I've said, it's increasing and continuing to increase. And lastly, we can have a falling point of inflection, where the curve is decreasing and then continuing to decrease. And a stationary point's nature, i.e. is it a minimum turning point, maximum turning point, rising point of inflection, or a falling point of inflection, is determined by the behaviour of its graph to its left and right. So basically looking at the stationary point and seeing what's happening on either side. Is it increasing or decreasing, or increasing, increasing, or decreasing, decreasing? And we can look at those behaviours using a nature table. So what we'll do is we'll go in with an example and you'll see how to use the nature table, and I'll explain what I'm doing at the time. So a curve has equation y equals x cubed minus 6x squared plus 9x minus 4. Find the stationary points on the curve and determine their nature. So we firstly know, in order to find stationary points, that we need to know what the derivative is, dy by dx. So dy by dx here is equal to 3x squared minus 12x plus 9. Now, we know that if we have stationary points from the previous slides, the gradient of the tangent at stationary points is 0. So we know that stationary points occur when dy by dx is equal to 0. Now this statement is very important. You must write this every time you answer a stationary points question. So that means that if dy by dx is equal to 3x squared minus 12x plus 9 and dy by dx is equal to 0, then this expression, 3x squared minus 12x plus 9, must be equal to 0 as well. Now, I need to solve that, which means I need to factorise, and in the first instance I can take out a common factor. and I can basically divide throughout by that common factor. So I've divided throughout by 3 here to leave me with x squared minus 4x plus 3 equals 0. And if I now factorise, get x minus 3, x minus 1 equals 0. And I have two answers for this, x equals 3 and x equals 1. So this is where my stationary points occur. Now, it's stationary points I'm finding. I now only have x coordinates, so I need to find the y ordinates of those stationary points. So at the moment, I have this, I've got 3 something and 1 something. Now, in order to find the y ordinates, I need to take these values for x and substitute them back into the original equation. Y equals x cubed minus 6x squared plus 9x minus 4. So firstly, when x is equal to 3, y will be equal to 3 cubed minus 6 times 3 squared plus 9 times 3 minus 4. And that gives us the value negative 4 for my y ordinate. And lastly, I've got x equals 1. So y will be equal to 1 cubed minus 6 times 1 squared plus 9 times 1 minus 4. And that gives me 0. So I have the stationary points, 3, negative 4 and 1, 0. So I have answered one part of the question, find the stationary points on the curve, but I still have to determine their nature. And this is where we use a nature table. Now, our nature table, we're going to examine each point separately, and we're going to firstly, we need the value of x, okay, which obviously in this case is 1 and 3. I'll just put those in order, in numerical order. We want to look at dy by dx for these points and surrounding points, and I know that dy by dx is 3x squared minus 12x plus 9. Put that in here. And then I want to just draw the shape of the graph, just to confirm to myself that I know what the nature actually is. So for the points 1, 0 and 3, negative 4, I know that dy by dx was 0. That's how I got x equals 1 and x equals 3. In the first place, I solved for dy by dx equal to 0. And if I had to substitute 1 back into this expression, I would get 0 out, likewise with 3. So I know that those are stationary points and their gradients are 0 at that point. So I can draw short horizontal lines there. Now, I want to look at values on either side of x equals 1. So I'm going to choose to look at x equals 0 and x equals 2. Now, I don't want a value any bigger than 3 here, and I don't want it to be 3 here either, so that's why I have chosen 2. And my values for on either side of 3, I'm going to choose to be 2 and 4. Now I know I've chosen 2 twice here, but I'm looking at 2 different points, so that's okay. Now if I firstly look at 0, I want to substitute x equals 0 into dy by dx. So that will give me 0 minus 0 plus 9, which is positive. And the shape of the graph when the gradient is positive is going up the way. So it's sloping upwards. Now when x equals 2, we've got 3x squared minus 12x plus 9. If we substitute x equals 2 in there, we get a negative. So the shape of that graph is going downwards. So you can hopefully see here that we would have part of a curve that would look like that. So we would have a maximum turning point. Now again, I've repeated my 2 here, so I can just transfer all of that information over here. That's fine. And if I substitute 4 into dy by dx, here, I'm going to get a positive, and the line slopes upwards. So hopefully you can see that the graph would look like this. So we would have a minimum turning point. So I then need to conclude. I'm not quite finished yet. I have found the nature, but I've not said which point's which and things like that. So I need to say, right, I've got a maximum turning point at 1, 0. You can see the maximum there, remember? And I've got a minimum turning point at 3, -4. And those then are my final answers. And we'll just look at the graph. So you can see here I've plotted the curve y equals x cubed minus 6x squared plus 9x minus 4. You can see that I've put on the points 1, 0 and 3, -4. And you can see at 1, 0, it's a maximum turning point. And at 3, -4, that's a minimum turning point. So you can see what we've done is correct then. So just now would be a good time to pause the video and take this down in your notes jotter. Okay folks, welcome back, and we'll look at a second example here on stationary points. So we want to find the stationary points of y equals 4x cubed minus 2x to the 4 and determine their nature. So remember, like before, if you want to find stationary points, that is where the gradient is 0, i.e. dy by dx. So we firstly need to differentiate. So we'll get 12x squared minus 8x cubed. We know that stationary points occur when dy by dx is equal to 0. Therefore, 12x squared minus 8x cubed is equal to 0. Now straight away here folks, I can see that I can take out a common factor of 4x squared, and in brackets I'll be left with 3 minus 2x. Now I could divide throughout by 4 here, but at the moment it's not going to make any difference. I'll have 4x squared is equal to 0 and 3 minus 2x is equal to 0. So from my 4x squared equal to 0, x is 0, and 3 minus 2x equals 0, that means that x is 3/2. Now I need corresponding y ordinates for these x ordinates here, so I get my full stationary points. So when I substitute my x values here back into the original equation, I will get 0, 0, and now the 3/2, obviously if I put this in here there'll be a lot of fractions, and that will get you 27/8. Don't be put off by the fractions, hopefully we are quite comfortable with those by now that we're in higher, so just make sure you know how to multiply fractions. Now, we have our stationary points, so we now need our nature table to find out what the nature of these points actually is. So we've got our x coordinates 0 and 3/2, and we know at these points that we have dy by dx equal to 0, the gradient is equal to 0, and the shape of those is, we just denote a wee dash, a wee horizontal line. So on either side of 0, I am going to look at the points -1 and 1, and on either side of the 3/2 and 3/2, I'm going to look at 1 and 2. So when x is equal to -1, substituting -1 into dy by dx will get me, that will be positive 12 plus 8, so that's 20, so that is a positive, which means that the curve will be going upwards. If we have 1, that will give us 12 minus 8, so that's 4, that's also positive. So again, the graph is going upwards. Now you can see I've repeated my 1 here for the 2 points, so I can just copy that information across. And when x is equal to 2, dy by dx then will be, let's see, so that will be 48 minus 64. So that will be a negative. And you can see that the shape of the graph is sloping downwards. So we have, firstly here, increasing stationary point, increasing again. So that's a rising point of inflection at the point 0, 0. And here we've got increasing stationary point, decreasing. So that is a maximum turning point at 3 over 2, 27 over 8. So those are our two stationary points and their nature. And we'll just have a wee quick look at the graph here. So you can see the rising point of inflection happening here at 0, 0, and then you can see the maximum turning point here happening at 3/2, 27 eighths. So again, just now would be a good time to pause the video before the screen goes blank and copy this down in your notes jotter.